Hi guys, welcome back. Today we're going to talk about what good science is. The key here is to look at this word right here, objectivity. So I want you to take a second and think about what objectivity is. What does it mean to be objective? So if you're looking for a straight answer, to be objective means to be able to look at all sides equally. So essentially, if your two friends get in an argument, you look at both sides and you choose objectively without taking one side over the other. That is very important in understanding how good science works. Okay. Here we have an example that your friend is having a chili cook-off, but you don't like beans. So can you taste all of the pots of chili and be objective? Okay. You are obviously going to like the chili without beans and not like the chili with beans because you don't like beans. Okay. That being said, you would have a bias, which that's the key word here. You are biased against any chili with beans. So you, as a person who does not like beans, would have a bias against any chili with beans. And going along with that, any of the chilies that have beans would be consistently rated lower. A sampling bias is if I took a random group of people and I asked them to taste all of the chili. Okay, so now I have a whole bunch of people who have tasted this chili, and I only take the people who don't like beans. So in this example, I'm only taking people who think the same way that I think. Now think to yourself, is that being objective? The answer is no. You are being biased. You are a sampling bias by taking only those people who agree with you and getting rid of all of the people who don't agree with you. So selection of the sample, you should be able to select anybody equally. So essentially, if I put everybody's name in a pot and I chose names out of that pot to be test tasters, then each one of those people would have an equal chance of being chosen. The sample size is also very important because not everybody has the same taste buds. Not everybody sees things the same way. Okay? So taking a small group of people versus a large group of people is not fair. I will not have the same favorite chili as, say, 5 other people. Okay? So in order to make it more fair, you have to add in a lot of people. So like I said, use a random sample. Everybody has an equal chance of being chosen, and limit the question to the specific group sampled. Okay, you should not be asking questions about the crackers that came with the chili if we're only testing chili. So independent duplication. Right here up at the top, independent. What does that mean? Independent means that you do things by yourself. You do things on your own. To duplicate something means that you are recreating the original thing. So I have 2 sweaters and I want to knit a 3rd sweater that is like my first 2 sweaters. Okay? If you have the same pattern, the same yarn, you should be able to knit the same sweater. Okay? If I give that same pattern and that same yarn to somebody else and they are not able to knit that sweater, either 1, they're not a very good knitter, or 2, you didn't knit the sweater the way you think you did, or the way you said you did. One good example of this, and it crops up a lot in science, is the example of vaccines causing autism. Okay, this came up in 1998, and the guy who published this study published exactly how he did it. Now, a lot of people have since looked at that same study and tried to prove this guy right. But the thing is, they were never able to prove him right. Everything pointed to the fact that he was either lying or he was paid off. And as it says right here, which is just a little bit of information about him, in 2004, they actually did find that he was paid by a group that has a conflict of interest. So it was actually a anti-vaccine group that gave him a lot of money to say what he had said. Another thing you want to look for is peer-reviewed journals. Looking at this over here on the right, you see the National Enquirer. And in the National Enquirer, you find a lot of crazy out there headlines. What you don't see here is how they proved that somebody is related. Even going into the article, you definitely won't find that. This is not a reputable news source. Looking at the article itself, the things to look for when you're looking for a sign of bias is the language used, the data that was used, and the source of the data. Looking at language, if it ever says scientifically proven, right here it says that science does not actually prove, but it seeks to disprove things. So be very suspicious of that claim. Emotional appeals, so money can buy happiness. Obviously, the emotion here would be happiness. You might be wanting to click on this because you would want to find out, oh, is this real? So it's really clickbaity. And then you see strong language. Use of strong language should not be necessary to convince you. The data should convince you. The last thing that I'm going to talk about is credentials. Okay, whoever it is that did this scientific study, I want to know what their background is. Do they have the proper background to make the claims that they are making? What kind of school did they go to? What kind of degree do they have? How are they relating this to their field? How much do they know about their field? How long have they been doing this research? All very important things in understanding whether or not something is credible. All right, that's it for today. Hopefully you kind of got a better idea of what a reputable news science source looks like. All right, see you guys later.